It's my honor to talk now. My name is Florian Kerschbaum. I'm actually a very young professor here. I'm only here since January, and this is the first time this course is being offered, so I can't, unfortunately, show you past successes of this course. It's a course which is at the intersection of encryption, which is rather a theoretical topic, and systems building. So it is actually applying encryption in a number of systems, and I will explain which systems we have, like databases, machine learning systems, or distributed systems, where we actually will focus probably on blockchain. If you look at the current system today, then we very often have cloud systems, and we have users. We have different users. They can send their data encrypted over the internet. So you have something like SSL. Everybody's using SSL, and you encrypt your data, send it to the cloud. However, the cloud decrypts, does some computation with it, and then before it stores, it encrypts again. So what we see is, while everything is encrypted, during processing everything is unencrypted. And this seems to be sort of a hard problem to solve. However, it seems also to be an important problem to solve, because if we look at recent headlines, and except for this one, which is a 2015 headline, but this is a headline where actually we have a loss of human life. And somebody read the news today? Somebody read about Equifax? So yes, okay, so we have one more. I should have added one more. So about 160 million records, including social security numbers, credit card numbers, have been stolen from a company in the US. And we see all these kind of things. So there clearly is a need for securing the data in the cloud. And customers are demanding that we have encryption. So we see Apple applying something, not encryption, but differential privacy. We see companies, there's startup companies like CipherCloud, Sky-High Networks, that offer these type of encryptions, because companies feel that they lose control over their data. If I outsource my data to the cloud, I suddenly have to trust someone else to take care of it. So why not encrypt it before I outsource it? Then I retain the key and I retain some sort of control. And the reason we're seeing more and more of these break-ins, of these cloud break-ins, is because these clouds are valuable targets. If you can steal 160 million credit card record numbers in one trial, even if you sell each credit card number only for $1, that's a lot of money, right? And also we have the issue of privacy, right? So if you're a user like using Google, the Google Cloud, using Android, you might worry about what Google is sending you as the next ad. So I always wonder what kind of ads are coming up in there seem to be two different streams very differently on different websites I recently visited. So you can worry about these kind of things. Of course, encryption would be a solution as well. I'm not talking about the economics here. So when you think about encrypting data when it's being used, you can take two approaches. So first of all, the naive approach of encrypting it the way we have encrypted before, of course, doesn't work anymore. We can't process the data anymore. So we need a different kind of encryption scheme. So we can either adapt the encryption scheme, and there is something called homomorphic encryption, which you might have also heard of. However, this is so slow that people are still trying to improve the encryption scheme. So in this course, we mainly look at something different. So we look how we can adapt the system that computes over the data to encryption schemes that already exist and that are sufficient enough. So there exists a whole bunch of alternatives to homomorphic encryption, and we look at how we can use those in existing systems. Now, we look at three systems specifically because they have been studied intensively. So we will look at databases, where the functionality is to basically search, but of course you can make it more complex. You can do joins, you could do sums, you can do group bys, things like that. And then the functionality already becomes more and more complex and not as well defined anymore, and a lot of problems arise whereas simple equality search is relatively simple. We look at machine learning, which is much less understood currently. We don't even know what the attacks are. So there are examples of, for example, where I can take a picture of a cat, and AI is really good at recognizing cats, and I just flip a few pixels, and they get different colors. And suddenly, I get a very different kind of output. So the cat is no longer a cat, although if you look at the picture, you see a cat. AI suddenly sees a dog. And what can we do in order to protect against attacks using encryption? And you might have heard of blockchain or Bitcoin. So I don't know if somebody uses here Bitcoin. So this is a system, I mean, that's very, very popular right now. A lot of people are trying to invest in it. However, the wide-scale adoption still faces challenges of privacy, which you could solve by encryption. So everybody knows that although you own a public key, that your money has been transferred to another public key in Bitcoin. Or how could I do sealed bit auctions, where I don't reveal which bit I had over a blockchain. There are systems like that, and we will look at these kind of systems. Okay, so how does the course work? We also have 3 hours lectures Tuesday afternoon. You only need to bring basic understanding of cryptography. So you don't need to understand how fully homomorphic encryption works. Fully homomorphic we basically don't use. But for the other things I give in the first 2 lectures, I give an introduction. I will teach you basically what you need to know so that you have the fundamentals. It would be also good to have a little bit of fundamentals about the systems, to know about databases, blockchains we will explain, but also basically how machine learning works. And then we also go in seminar style, so you will present papers. You will have a project. The project can be different types. It can be, of course, inventive, that you bring up something new, that you new algorithm, new method, new implementation, whatever. It can be repetitive, like we had just before, that you redo a project that's existed and verify that the results under different conditions are correct. Or it can be analytical, that you just do a survey of different kind of things. And if your project is more theoretical, then we can talk about counting this course not towards the database area, but towards the algorithms and complexity area. So you have these different areas that you have to cover with your courses. So if you want to be more theoretical, we can find a project for you there. You see the rather standard distribution about grading. And that's basically what I can tell you about the course. Maybe you have questions. And if not, you have a break now, right? Okay, thank you.